To start out with, I've got a blank scene here, and I'm going to go ahead and create a cube, which will be kind of the stand-in for a player character. It doesn't really matter where the cube is. Let's jump straight into the script for player control. My script is going to be called player control, and by clicking on the add component button down here, I can type in the name of a component to add, and if I type the name of a component that doesn't exist, whether or not I have a bunch of typos in that name, it will suggest to create a script with that name. So I'm going to create and add that script, and I can open the script in whatever editor is assigned by double clicking on it here. I already had my script editor open. I'm using Microsoft Visual Studio, and sometimes when you add scripts to a solution, it gives you a little message like that, but I'm not going to worry about it right now. This is fairly empty to begin with. I'm going to be using the fixed update instead of the update method. Basically, methods that are named update will do just that. They'll update every time either a frame is calculated or every time the physics update is calculated. Fixed update uses the physics update, and I'm going to be putting my code there. Alright, to start out with, this needs to get input from the player, and I'm going to store that input in a variable called a vector3, which is a type of variable that holds 3 numbers, sort of 3 dimensions. Within the input class is a method called getAxis, which I'll talk more about in a second. An axis, there are 2 axes declared by default in Unity, and they're vertical and horizontal. So for the first element, a vector3 looks like this. There's 1, 2, 3 numbers inside of it, 3 float values. You can think of these as being called X, Y, and Z. So in my game, Y is going to be up and down, and X and Z are going to be the plane that defines the ground. So pushing forward on the axis, on the vertical axis, will be forward movement. So I'm going to put getAxis vertical, plug that into the first, you just plug that into the first component of this vector3. Actually, I'm declaring a new vector right here, but in order to save that, I need to name it like this: vector3 direction, I'll call it. This will be the direction the player is inputting, which equals this new vector3, where we're collecting the input. In Z, I'm going to use a very similar statement to this getAxis vertical, except it will be horizontal. So now that variable named direction is storing the information from player input, and we need to apply that to the cube object in some way. Now in order to modify so what I'm going to do is modify the transformation of the cube object. So within the transform, now just to explain, transform here refers to this property of the cube, its transform, which we can reference and edit using methods within the transform class. The method I'm going to use is translate. Now if you plug a vector3 into the translate method, then that will modify transform over time. It will modify it every time fixed update runs, which, if our game is running well, should be about 30 frames per second. If I put the direction vector3 into that method, we can see that there are no compilation errors. I'm going to hit Control S to save that script and jump back into Unity to see what result we got. If I start to play the game, as I use the WASD buttons on the keyboard, the cube is moving around very fast, sort of uselessly fast, but this does give me the impression that my script is mostly working. It's not quite ready yet. There's a couple more things I have to do. Now let me play the game again and move this camera down here so we can get an idea of how the movement is taking place. Now when I press W, the cube moves back and forth. So in order to make this demo a little simpler, I'm actually going to reverse the two axes that I put in so that it will move away from the camera when I hit W, as if W is forward. And in order to do that, I'm just gonna paste, whoops, I'm just gonna swap these, horizontal for vertical, hit Control S, and over in Unity, let me show you really quickly where these axes are. I am looking for the project settings input. By selecting that, it shows the input manager in the inspector panel. So all of the inputs are managed under this axes category, and I've already added a couple to this project, but by default there exist these two called horizontal and vertical, and you can see that these receive input from the horizontal, for example, receives input from A and D, and it is repeated down here or somewhere horizontal. In this one, it receives input from a joystick axis, which makes this compatible with a controller as well as the keyboard, where right here it takes left, right, and A and D. So that's the reason we use the axis name instead of just directly referring to a key, so that we can use the input definition to remap that control without modifying our script. So now that I made that small change, the cube will move back and forth as I press W and S, and A and D will make it move left and right. Now it's moving really fast, and in order to control the speed with which it moves, I'm going to implement a couple of customizable variables that the designer can use to adjust that speed without needing to edit the script every time. This first variable is a float called move speed. Now if I declare this variable like so, it will only appear, this defaults to being a private variable, which means it can't be referenced outside of this script. But if I call it a public variable like so, that changes some of the ways that this variable can be referenced, and one of the things it does is it makes the variable accessible from the inspector. Now once this script updates, it should appear right here. Yes, here we have move speed now. Let me close that. So move speed isn't doing anything at the moment, but I can customize it here. So let's incorporate move speed into the direction vector so that it will have an effect on how much horizontal and vertical are updated every frame. And another thing I'm going to do to limit the speed with which they are updating is multiply this vector 3 by time dot delta time. So to explain this, the time class is used to measure how much time is passing. Now inside of the fixed update method, delta time will return a number, a fraction of a second, based on how much time passed between the previous and the current update. So just by using this, it basically is dividing the direction number by whatever 1 divided by 30 is. It should be dividing it into about a 30th of a second so that it doesn't move quite so fast. And while I'm here, I will also multiply it by that move speed variable so that now it's both updating in accordance to the actual update cycle of the application as well as a user-defined move speed. If I save that script, hop over to Unity and allow everything to compile, now when I play, already the cube is moving much slower, and I can adjust this on the fly to dial in the exact speed that I want. Somewhere around 30 is pretty fast. Maybe I'm looking for about 20. And this number can always be changed later. Now, the important thing to remember is when these fields are edited as an application is playing, they won't save their value when you stop playing. So one way to get around that, one way to make your changes final is just to remember what they were, and then when you stop, remember to go plug them in and hit Control S to save your scene. So now the cube is able to move around, and we can always change the speed that the player controls it with later if necessary.